Okay, so we just finished up talking about how to solve and graph inequalities. And there's one little exception to the rule, because there always is. So if I have to multiply or divide each side by a negative, I'm going to flip the inequality sign. And I'm going to show you how to do this, and I'm going to show you why. So I have x over negative 5. So x divided by negative 5 is greater than or equal to negative 2. So as soon as we see that we're dividing by negative 5, we know that to undo that, we're going to need to multiply by negative 5. And because this is written as a fraction, I'm going to go ahead and make my negative 5 a fraction by putting a 1 underneath it. On the other side, I don't need to do that because that side's not a fraction. So when I do this, my two negative 5s cancel each other out to 1s. And so I have the x there. And negative 2 times negative 5 is positive 10. And you're like, oh great, x is greater than or equal to 10. Here is the problem. If I go back and I sub in that 10, I'm going to do this on a post-it note here. If I go back and I leave that the same and I substitute in the 10 up there, so we're going to see, is this a true statement when I substitute in my positive 10? So when I put my positive 10 here, I check it out, and I'm like, oh, negative 2 is greater than or equal to negative 2. That's true. So if I want something greater than 10, I'm going to put in maybe 11. Let's do 15. It divides nice and evenly by negative 5, doesn't it? So 15 is indeed greater than 10, which is what we said we think the answer is. Now when I do this, I'm going to get a negative 3 is greater than negative 2. Well, we know that if we look at our number line, negative 3 is further away from 0 than negative 2 is. So this is not a true statement. In order to make the statement true, I'm like, oh, I need to flip that sign. Well, any time that I multiply or divide by a negative number, I'm going to need to flip that sign. So in order to make this statement true here, like this one, I'm like, oh, I need to flip that to make it true. That's because anytime I do that, I need to flip it here. So I do indeed flip the sign because we multiplied both sides by a negative number. In case you want to make that note for yourself. Now when I go to graph this, it's going to be a less than 10. And once again, I don't need to go from 0. I can go 7, 8, 9, 10. This is a less than or equal to sign, so I am going to have a closed circle, and less than tells me to go to the left. So my graph looks like that. I'm going to do the next two. I encourage you to turn off or pause this video and then come back and watch it and see if you got it right. I have negative 3 times x is greater than 6. I'm going to divide by negative 3 since I am dividing by a negative number. Negative divided by negative is going to give me a positive 1. So I have x is greater than negative 2, but because I divided by the negative 3, I am going to actually flip it. And it's going to tell me that x is less than or equal to negative 2. Close circle again because we have that little line, that less than or equal to sign there. want to include negative 2 as a possible answer. Our last problem there, negative 3x is greater than or equal to negative 6. I'm going to divide by negative 3. Now, it doesn't matter if my answer is negative or positive. It only matters that I'm multiplying or dividing by a negative number. Since I'm dividing by that negative 3, even though my answer is going to be positive at the end here, I still need to go ahead and flip that sign. I'm including it, and when I flip it, it does indeed become less than again. And there you have it.